today. So today I'm not going to talk about technical details. Today I'm not going to talk about circuit design or anything else about the technical. I think the next speakers can do that much, much better than me. But what I would like to talk about today is to give you more holistic view. Because we spent collectively a lot of effort in developing new technologies. So we collectively spent a lot of effort in developing new technologies, thinking about new ideas. Also at IMEC we are really deep into new technology development. But we also must admit that in the past years, a lot of effort has been spent in technologies that never make it into the market. It's a huge waste. So besides the technology development, we also need to think about what are the methods to make sure we can apply those new technologies into the market so that they solve the real problems. If a technology cannot solve the real problems, it has no benefit for society. So that's what I would like to focus on. So I will give you a few examples of what keeps us busy at IMEC. What are we doing? These are real life examples. I will also give you some indication of what we see as a major trends and why we are very excited. Actually, these are very exciting times. And we do that based on our international collaborations. I think we work with more than 600 companies worldwide. So by working with all these companies, we can detect what's the major trends, no matter for the big companies, but also for the startups. So that's why for today's presentation, I try to use the title, Making Difference in Shaping the Future. And as I already gave a warm-up at the coffee this morning to my former Axel Phillips colleague, actually these are very exciting times because what we see that there's a new wave of hardware innovation. And I do not know everybody's background here, but you know, a few years ago, everything is about software. If you work for Google, you are hot. If you work for a chip design company, you are not hot. This is changing. It's changing fast. And that's why we are very excited. And I will tell you later on why. Actually, if you look many, many years ago, life is relatively simple. You know, Microsoft, they sell the operating system on a floppy disk. And Google is still the real software company. But these times have changed. These times have changed because all these pure software companies, they realize that by using the standard hardware platform, like a Wintel, actually it cannot fully exploit the benefit of their algorithms, of their great software. So what is happening in recent years is that all these software companies, they want to innovate, not only through the software, but also by developing their own custom hardware. Today, Google also sells hardware. Even the AI speaker. So these are exciting times because what we see is that everything as a service is really driving this innovation. It's not because Google wants to per se become a hardware company. No, because everything becomes a service. Not only software, but everything. And basically this trend is disrupting existing businesses, recent business, but also very old businesses. And why is that? Because actually it's not about the hardware, it's not about the software, it's about the data. The people who hold the data, they hold the power. But if you use a standard hardware platform, how can you differentiate? The Alibaba, the Amazon, whoever, if they all use the same hardware, they get the same data. And they can do data analytics, maybe you can get some better result, but at the end it's the same data. So you need to differentiate. And this trend is really accelerating. We see more and more companies asking this kind of question. Hey, how can we design our own custom hardware to collect the data, to differentiate, to get the optimal sensor quality, so that you get better data. And of course, that with your strong algorithms, high-performing algorithms, you can get more and better results. And that's how you can differentiate as a service. So more and more companies have this desire to make their own hardware platforms that provide specific data, not just a standard platform, but optimized sensors, optimize the hardware. And we can see this trend in healthcare, smart mobility, but definitely also in industry. Industry 4.0 is really booming. We see a lot of requests there. Maybe not so much in the consumer. Consumer today is about speaker, etc. But really industry 4.0 is really booming. And everybody talk about these known examples, how to create a specific data, but what does it mean for everyday life? I give you one example of a project we have been working on, and that is with this sir. I don't know if you know him, but Peter Hanou, actually he's a world champion, latte art. I'm not an expert in this, I just drink coffee, but you know, some people are really crazy about coffee and they make some designs, etc. It's a very special. He's also the ambassador for Barry Callebaut. Barry Callebaut is the largest chocolate company worldwide. So this is really serious business. So we work with him on a project, how to make a special latte art machine. Connected to APP, download some program into the machine from remotely, and I give you some advice. And of course, the real benefit here for the latte art specialist is that how can they rotate the cup? How can they measure viscosity? How can they measure the temperature at different locations in the cup? Not just a one-point measurement, multi-point measurement. So how to build in some artificial intelligence that usually only the human being possess. So this is a real-life project. It does not always need to be about the robot and the speakers. It's a real-life project. And you would be amazed how much data this kind of a simple special coffee machine with the APP generates. You cannot just send it over Bluetooth only. You will not get a very perfect coffee. So this is just a simple example of an entrepreneur who has an idea, who has a great idea, who has been able to raise the funding, to raise the capital, but they need help to create a specific hardware that does not exist worldwide. And we see that there's a booming growth, booming demand for connected devices, no matter that it's a special latte art coffee machine or that's some kind of equipment in a factory. There's more and more connected devices. And of course, we also see this substream innovation. In the past, it's those big companies like Intel or Compaq or HP, they drive the innovation. Now we see that startups who drive innovation. Many small companies, many entrepreneurs, they try to use lean budgets to innovate. It's what we call the substream innovation. And of course, we see also a big new wave of hardware startups. Actually, the hardware community in Europe, in USA, I think also in Taiwan, more and more, is really thriving. More and more startups are happening, and especially in the hardware. Several years ago, if you are a startup, and you are called a Facebook, or you do some software programming, you can get money from a VC, from venture capitalists. If you want to design a chip, it's very hard to get money, or hardware, or anything related to hardware. That is a changing. That has changed in the past few years. And we are very excited about that. There's a lot of VCs, or ecosystem investors, that realize actually the trend is not only in the software, it's in the together, the co-design together with the software and hardware that really bring this innovation in everything as a service. And that's why those VCs started to invest again into hardware startups. Many of those hardware startups are our clients. So we feel very excited about that. Of course, I think in the same time also methods have changed to develop products. And that's very important. Because those big companies like Intel, HP, etc., they have huge budgets. But usually startups do not have. So if you apply the same methods as in the past to develop products, it will not work. So what we see in the recent years is that more and more of these hardware startups or medium-sized companies, they try to apply the agile development methods that originally emerged from a software development, like a Scrum. Now we apply it to hardware development. So what it means that we look at what is the minimum viable product. We try to make a very, very fast, quick iterations, so that you can move forward to the desired result with a lower risk. Instead of starting with the specification and then build the wheels and etc., you end up with a car. You go in the much smaller steps and you do the quick check with the end client. Is this really what you want? This is not a new method. It's being popular in software development for years, but in recent we see more and more hardware people applying this Scrum or Agile methodology as well. I think another major trend is the revival of ASIC technology, application-specific IC. And it's back, and it's more alive than ever. I see you looking strange. Oh, what is he talking about? ASIC technology. Everybody knows. So, now you have 3 nanometer technology you can buy from TSMC next year, right? Actually, if you look at this curve from the 80s to recent years, you can see evolution. You have a telecommunication in the 80s, you have a mobile phone, smartphone, and the use of chips, the use of ASICs is growing tremendously. Semiconductor industry growth has been outperforming the rest of the industry growth for many, many years. But around 2010, you can see a decline in the amount of companies who can follow this kind of race. Today, you have a Qualcomm who make mobile phone chips. In Taiwan, you have a MediaTek. Maybe you still have a Broadband, but there's not so many companies left. 10, 15 years ago, I need 5 hands to count how many companies there are to develop a mobile phone chip or tablet, the chip for tablet PC. Lots of companies, not only in Taiwan but worldwide. Around 2010, there's only a handful left. Because it becomes so expensive to follow this kind of a game, to follow this kind of a speed race, that most companies cannot afford it anymore. How many companies can still afford the 3 nanometer chip technology? Not too many. But what we see in recent years, and this is really only in the past few years, we see that the amount of tape-outs, the amount of ASICs is growing again tremendously. And the reason for that is the IoT. And especially if you look at healthcare, smart mobility, smart industries, they all need the chips. Of course, they don't need this 3 nanometer or 7 nanometer or 20 nanometer technology. We use their legacy technologies. Many of these products that we are developing at IMEC together with our clients, actually we design them to be market ready. All the examples that I give today are real examples. And often people come to us with an idea for a system or a need for a certain solution or technologies, and we work with them to bring it from the technology point of view up to the product level. But of course, as I mentioned in the beginning of my presentation, it's very important that you can also penetrate the market. Often we see that these ideas for disruptive applications, for disruptive services are really good ideas, but the way to implement the technology is way too expensive. Either maybe the power consumption is way too high if you use off-the-shelf technology, if you use off-the-shelf components, discrete components, or maybe the system is too large, or there can be other reasons. So that's why many of these startups, medium-sized companies, eventually they decide to make use of the ASIC technology. Because the ASIC technology can bring advantage for cost, factor 5 to 10 better cost, but it depends on volume compared to discrete components. You can see also power consumption can be reduced 5 to 10 times, and often that's very important, especially for IoT where you have sensors somewhere located in the room. You don't want to change batteries every week. And why do I all tell you this? Because not so long ago, only a few years ago, everybody just want to program systems. You have a GPU, you have an MCU, just the right software. You can program anything. That trend has changed tremendously. So ASIC technology has become much more affordable in recent years. And again, I'm not talking about 7 nanometer or 3 nanometers, but I'm talking about chips, ASICs, that are affordable for IoT companies, for companies that develop new application sensors, etc. Here is a bit of a complicated chart, and for those people in the back, I think it's difficult to see, but you can have a look at the handouts. Here you can see over the years, I think it's about 10 years, you can see different technology nodes, like 16 nanometer, 28, 40, 45, 0.18, etc. And this graph is actually the tapeouts that IMEC do together for customers. So each of those bars is some accumulated tapeouts for customers. Per year, we do about 500 tapeouts, 500 chips per year at IMEC. So you can actually see that today, 65 nanometer, even 0.18 is very popular. It's very popular because those technology, they are very mature, very cost effective. You can find the different suppliers, different foundries, many foundries who can provide this to you. So this is an ideal solution for many of those IoT companies, for many of those startups. Unless you are Apple, unless you are Broadcom or Qualcomm or MediaTek, yes, you can afford 10 nanometer. But the reality from the daily practice today, you can see that those technology nodes are the most popular. So 85% from our data, from our statistics of our clients, they don't need this most advanced technology. For power consumption, for cost reason, if you find the optimal trade-off, you will find you can do with a little bit older technology. So this is the practice. You can also see that there's a shift in recent years, and I talk about 1 to 3 years, that the amount, the quantity that you need in order to get a profitable break-even, or come to a break-even point if you want to develop your own asset, can be reached much sooner. Many years ago, unless you are able to sell millions and millions of chips, you cannot make your own chip. Yeah? You cannot make your own ASIC. Today, if you look at the real data, 500 tape out per year by IMEC, you can see that actually that amount, the point when you get really return on investment, comes much sooner. With a quantity of chips at 10 times less than a few years ago, you can already achieve this break-even point. And that's really exciting. And why I all tell you this is that if you look at the IoT, if you look at the edge, etc., for 5G, it's all about a massive amount of sensors, new devices, new applications, new services. But if you use an old methodology to design, if you use an old technology, standard platforms, just a programming software, you cannot bring down the price point. It will prevent all these startups, all these entrepreneurs with new ideas to enter the market. So that's why this kind of a trend is very important. I think also one major trend is that people look for single end-to-end partner. In the past, when you want to develop an IoT product or some new product, you work with the mechanics of one company in a Kaohsiung. You work for the chip, you work with the company in the Hsinchu, and the software you work with the company in the Taipei. And maybe for industrial design, you need to work with a company in Switzerland. Those times are over. People want to spend more effort on the marketing, on the look and feel. It's more important. So technology barrier should be much lower. So we see those companies, those service providers who organize themselves to have a full service portfolio, they can really thrive. So that's also a major change for those companies like a Quanta, like a Foxconn, etc. In the past, they do assembly. They turn the screws, they make sure they can do the assembly in the most optimal way, most efficient way. Today, they also need to have a more engineering power on board. The times are over that for assembly you go to Foxconn, and for other things you go to other engineering companies and you try to coordinate. No, that is not longer true. So this is another example of a device we developed with one of our customers in Europe. Actually, they won last month the best 2017 Best IoT Product Award. And basically, when we use it for, it can be 4G, because of 5G not deployed yet, but it's prepared. Actually, it's a sensor hub with a high-speed wireless communication, but also 15 sensors inside to do environmental monitoring and VOCs, etc. So one application area here is to, and maybe you know this company, JCDecaux, it's a French-Belgian company, the largest advertisement company worldwide. You can find also in the Taoyuan airport, you can find their displays. And what happened is that this is a trial in Paris, and the little box that I showed you before is being built in these advertisement panels. And the people who walk by, they get the free Wi-Fi. Of course, a Wi-Fi free, that's not the service. The real service is to measure the demographics. How long are you standing in front of this advertisement panel? Are you male, female? Do you come back? Do you like it? Do you smile when you look at this advertisement? And do you come back? What's the temperature outside? Is there any relation? Maybe if there is an advertisement for ice cream, outside it's a 40 degree. Yeah, maybe you stand in front more longer, right? This kind of a demographics. That's the data the advertisement company wants to collect. Yeah? And of course, it's a huge amount of data. Yeah? Because you need to do face recognition, you need to measure all these 15 environmental parameters. Yeah? You need to do image processing. So you need to be quite performant to the system. Yeah? And you need to send all these data into the cloud. But it need to be compact, low power. Of course, we have also the big trend in aging society. Yeah? I think many people already talk about that, and there's many solutions. Yeah? And this is a company that has deployed actually in the past year all over Europe this monitoring band for senior citizens. Yeah? It comes with the geofencing, it comes with the tracking, it comes with the sleep pattern monitoring, but it also comes with fall detection. The nice thing that this has been clinically validated. Most of these fitness bands out of the market, they are for fun. They work, somehow you get a number, but doctors do not trust it really. Even like security or nursing homes, they do not really trust it. So it's very important that you clinically validate it. So we work together with the university. Actually, we work together with 2 universities, including Sports University in Taipei, to develop algorithms for fall detection and also to clinically validate it. So not only we can detect automatically when people fall down, there's many different ways you can fall down, but we can also predict what's your risk you are going to fall down. What's the chance that today you will fall down? And I give you some warning. Hey, maybe you better sit down for the rest of the day or take it easy. So this kind of preventive algorithm is very important. But the important for IoT device is that we do not emphasize on the technology side, but we try to solve the real problem. We make sure that we differentiate from the toys, and that we spend the effort not in developing technology, but developing the application and make sure it works well and that people can trust it. I think a lot of growth and requests we get also in the medical life sciences. There's a lot of opportunities for semiconductor technology to further improve life science instruments. And of course, we have this kind of physiologic monitoring. We see a lot of requests for tools to help in revalidation. Because today, if you break a bone, if you have some epileptic seizure or other kind of issues, often you need to go to a special revalidation center or specialized hospital. But if you can do the revalidation at home and do the follow-up at home, it saves costs for society, but it also makes that you can do long-term monitoring, not only at those points that you go to the hospital. So we see a lot of effort there. I think another example is what we call the smart shelf. Many startups are working to disrupt the retail business. Retail business is actually a very traditional business. It's dominated by those huge companies, like a Unilever or B4G, etc. The problem there is that who holds the data? Who knows what do you buy? You buy chocolate paste or you buy noodles? Who knows that? It's the retailer who knows. Because they can easily monitor how many products are there still in the shelf. But the product company, they don't know. Unless they pay a lot of money to the retailer to buy the data or to buy some marketing report from some companies. So we see a lot of our clients trying to disrupt this kind of a traditional chain by including smart electronics, smart tags into the bottles, into the individual products, so that they can be monitored easily. So this kind of smart shelf concept, we see a lot of requests there. Of course, there are challenges. The lady here is holding a plastic bottle. That's an easy case. But what if you have, for example, soup with a metal can? Many of these RF technologies, they do not work well if you stick an antenna on a metal surface. So you have to work with spacers, you have to optimize antenna design, you have to come out with other solutions. Also, what you can see here is that in these shelves, typically all the products are very located very near to each other, because the shelf position is very expensive. So all these packets are like a few millimeters from apart. So one of the things we did here is to develop algorithms and a system that you can read out each individual package, no matter they are located next to each other, or in parallel, or in real time. The problem is that you have to avoid the collision. How you can identify unique packages, even they are very near to each other. So you have to optimize the RF technology, the antennas, so that you can distinguish between individual packages. That was not present in the existing off-the-shelf solutions. So this is just one example where we try to innovate and where we try to bring some disruption. And this is one of the examples of printed electronics. And I know many of you have a semiconductor, CMOS semiconductor background. But actually, we see a lot of growth and potential demand and applications also in the printed electronics. No matter we use a conductive ink or we use oxides, oxide transistors. The real nice thing is that you can use the traditional TFT display factory line to produce those printed electronics. Nowadays, the LCD or the display industry is a display under big threat. Prices go down. Companies like AUO or Sharp, it's not an easy business. So there's a lot of overcapacity. But those production lines are ideal to manufacture this kind of printed electronics. With some modifications, we can leverage from those installed manufacturing capacity. And it comes at a cost that is much lower than silicon technology. You cannot beat this printed electronics from cost point of view. Disadvantage, of course, is that those oxide transistors are much slower than silicon technology. But for those smart shelves, to read out what's the positioning of a package in a small shelf, it's fine. Speed there is not so important, but cost is very important. So please watch out in the coming years for printed electronics. And then, of course, we have the industry 4.0. No matter that's robots, the labor cost worldwide becomes too high. Even in China now, cost becomes too high. So you see a massive trend to replace the people by robots. And in the past, the robots just have a very simple function. They just need to pick and move some object into another box. But also there we see a lot of disruption happening. And a much more intelligence being added, no matter to the object that the robot needs to replace, or also in the robot itself. There's a lot of work happening in imaging, like this kind of smart cameras. And everything has to do with the improvement of efficiency. And companies like Amazon are really driving this kind of a trend. Maybe now you still see the pictures of or the news about people moving books into carton boxes and then ship them by post if you order them online. That's almost finished. All these people are being replaced by this kind of robots. But you want to make sure that the correct book is in the correct parcel to be delivered to you. So how can you replace those people? You need to make the robots more intelligent. So when we talk about the IoT, 5G, etc., people always think about consumer devices. If we look at all reality or daily business, and actually most of the cases we have on hand is from industry, not from consumer. Usually consumer adoption lags a little bit behind. And I see also some young people in the back, so I included a few slides also, hopefully to inspire those future generation of entrepreneurs and technologists. And we are talking often with the startups and with young people also trying to work with the IMEC. And adoption of a new technology also comes with a lot of the challenges. Because how do you know you are working on the right product? How do you know? How do you make sure you develop the right product before you run out of money? And actually, as this quote says, you don't have a time to develop the wrong product because you never have enough money. There's always some competitor, someone listening to your ideas, try to copy that. So time is very important. And what you see here is that actually, what we see often in the market is that it's not by default that the smartest people survive. It's not by default the people who have most money that survive. Mostly it's the people who are the fastest. And you see these two kind of companies that we always typically meet. The one company, actually here you can see the expenses and time, and then here you can see the time that the company should bring their innovative product to the market. And of course they start from scratch, both of them. And the one company, they try to develop everything by their own, in-house. But they cannot get the product right. So even after they bring the product to the market, they still keep developing, fine-tuning, trying to get things right. And they keep burning the money until they run out of the money, and then they lose. Some other company, they follow this kind of agile scrum method. They go in little steps, try to get the product almost right, at least the minimum viable product almost right, so they have something they can launch, and then the development cost immediately drop. Maybe not to zero. You still need to maintain certain investment because you need to make some updates, further updates, or small improvements, and you get it right. What's the difference between those two companies? Well, the big company, they try to do everything in-house. Many young guys, they think, okay, I know everything, I can do everything, just give me money, give me time, I will do it. Also, many people, they are very concerned about the IP rights. If I work with too many people, the information will be on the street, and the people will run away with my idea or my design. Often you cannot protect a certain design. Often you cannot easily protect your algorithms. So you better not work with too many people, because maybe someone is taking note. So that's a major issue what we see. So that's why we always try to collaborate and tell them, no, you should work with partners. I think this slide is a mix-up a little bit. So basically here, what I want to say is that, as I mentioned a few minutes ago, is that basically most of the cases what we see today, 500 tape-out per year, or the other system developments that we do, that actually a major part of these opportunities come from the industry. Yeah? And the adoption rate for consumer is actually much smaller. I know for the newspaper and some conference, of course, they always talk about this very attractive product like Google or AI or these buzzwords. But the reality shows that the most of the case, also for 5G adoption in the future, is for industrial application. And let me bring that a little bit further. If you look at the industrial application, if you look at the sensors, yeah, then one of the application, of course, this conference is about the radio technology, among others. Then actually, if you talk about always connected, because you need to transmit all these data created by the sensors and algorithms, etc., you have to look at the connectivity. And I think everybody reads the magazines and newspapers, and everybody predicts, okay, the amount of data that's being transmitted into the cloud is going to boom. So there's a big problem, because always connected, yes, you need to have that, but how do you do that in relation to power consumption? Today we are at the point that actually all these high computation intensive algorithms, we can simplify them, and we can reduce the power needed to do the computations. So in this picture, you can see that actually most of the power consumption in such kind of a system or asset is not because of those software algorithms, but due to the connectivity. The radio consumes most of the power. In the past years, actually, we have been focusing at IMEC how to design ultra-low power radios. Because the software algorithms, you can relatively easy downscale, you can optimize them for power consumption, you can implement all kinds of user scenarios to reduce the power, but the radio is a key element. I think this year we have also submitted some papers for the ISSCC conference. And this is some of the designs that we made in the past 10 years. So a key factor for all research and development at the IMEC is to continue to work on reducing the power consumption of the radios. And I just gave you the example of a Bluetooth. What is a Bluetooth? That's old, right? Who still talk about Bluetooth today? We talk about 5G, right? That's why we are here. Oh, you're wrong. There's still a lot of work to be done to reduce the power consumption of those legacy radios. We always have the habit to jump into the future, right? What's going to happen in 5 years? But this is a reality. Maybe you can make your backbone very fast. You can have all these small cells, etc. I think later you will hear about the network. But how about sensors? If you burn your energy, if you burn the power in those sensors, actually still useless. So that's why even on the academic side at IMEC, we still continue working on this. Very, very important. The work is not done yet. And this is some examples, and I don't want to make advertisement here, but just to see that this is a reality, even for the big companies like Renaissance. We work on the 2.5 gigahertz IP with them. They implement that, come out the real chip, recent. And you cannot see it from the back, but if you are here on the phone, you can see this is some announcement, online announcement in 2013. 2013, the people talk about how to reduce the power consumption of a radio. This is an announcement in 2017. So the issue is still very hot. Even we are so many years later, the work is not done yet. Not from research point of view, even not from those big company point of view. So I think why we all try to do this, because if you talk about the IoT, if you talk about the edge and the fog, etc., you must reduce the cost of all these sensors. Yeah? The cost is, of course, in the ASIC. I already talked about that. The ASIC technology becomes more affordable. Yeah? I talk about the new design methodologies, so we can have a more quick time to market. Yeah? But we also cannot scale battery. Yeah? Unfortunately, batteries still today we cannot scale. Yeah? So we need to apply the system using the smallest possible batteries, yeah? At the smallest possible cost. That's why we all keep doing this kind of work. And there's many new services happening, like proximity services, indoor tracking, yeah? But also security. Yeah? Security is a major issue. And when I go to almost last part of my presentation, basically if you look at intuitive IoT, how can we make that successful? Of course, we need to have exciting new technology. Yeah? Of course, we need to disrupt there. But in the first sentence of my presentation, I promised you I will try to give a more holistic viewpoint. How can you make an adaptation of a new technology successful? Of course, you need to have attractive technology. Of course, you need to have always connected devices. So you need to work on reducing power consumption of the radios. No matter that's a legacy radios or that's a new radios, you need to work on reducing power. You also need to make sure that you develop methodologies, design methodologies, so you not only put your effort on the technology, but also on how do you use the device. The look and feel, is it intuitive, is it trusted? Often engineers forget about this point of view. But an important aspect that most people don't touch about is you need to test, validate new technology in real life. Yeah? Not only in the laboratory. In the last pages, I would like to spend a little bit of time there. Yeah? So at IMEC, we set up this project what we call Smart Cities, and we work together with the Port of Antwerp. Antwerp is a little bit similar to Kaohsiung. Yeah? It's one of the major harbors in Europe. Yeah? And that is very interesting. So what we did in the past year is we worked together with the city government of Antwerp, and we deployed many sensors throughout the city, throughout the harbor. Yeah? And why do we do that? Because we get a lot of requests from local city governments or companies or even citizens. They say, okay, well, yeah, you work on this advanced technology, but how my family can become better, right? How can we use this? Huh? How can it benefit for society? And that's the point that many people forget, that when we talk about the IoT, about smart cities, we always think about the technology. Huh? Of course, we are engineers, we need to talk about technology. But actually, it's about improving issues in daily life, not just about deploying technology. Yeah? And let me give one example. This is example of the national mail company, post company. So what we did is that we put a little box on top of each event. You know, in Belgium, people have become a little bit lazy, so the postman is not driving his bicycle anymore. That's 20 years ago. Today, the postman, they drive the car. Yeah? So each car we equip it with some sensors. Yeah? So we can measure road quality. Are there any bumps in the roads? Yeah? We can measure air quality. Yeah? We can measure congestion. Yeah? So city government can easily detect, hey, do we need to repair this road? And of course, the postman, they visit every house. So the granularity over there mapping is very, very fine. So why I highlight this is the fact that test bed, the real life validation, real life verification of a new technology in the real environment is so, so important. 10 years ago, we didn't do that at IMEC. We just stay in the lab, yeah? And we bring out a new technology, we make some press release, done. Test that, smart city validation, that's something we started doing in the past 2 to 3 years. Yeah? And then you need to partner. Yeah? And these are some examples of real cases, buildings, nursing homes, hospitals. I talk about a mail company, the post. Yeah? Of course, we need to partner. Yeah? Often these companies, they are not really technology oriented. They are often very traditional companies. Yeah? So we need to spend a lot of effort in convincing them why they need to work with a research institution. Yeah? Because they think, okay, this is all academic. Well, what's the benefit for us? It's also something we have to learn at IMEC. Yeah? So this kind of a test bed validation becomes a very important activity at IMEC. Not as something that a few engineers doing, but really something that from corporate point of view, we very much believe in. Maybe for the engineer, originally this is not so exciting. You know, you already prove in the lab things are working. Now there are 1,000 reasons why it works in the lab, but maybe it does not work on the street. Yeah? And those reasons make that later on companies who want to license the technology, they will believe in it, but they will not believe in it. Because how can you prove it? If it works in the lab, you can prove anything. Yeah? So I think it's very important that we have the integrative approach. New technology development, yeah? We do the system integration. We also help companies to develop prototypes. If you talk about medical device, you need at least 1,000 pieces in order to do the trial, the real trial. We also need to spend the time in training. It's often something we neglect. How can we convince people that the new technology has some benefits? And of course, we need to work with the suppliers. Just like I give the example of the mailing company, or many other suppliers. Now, why I show you this is to indicate that even IMEC as a research institute, we exist for 35 years. We also gone through evolution. From a pure focus on the technology development, what we are still doing is still our major core of activity, to also integrate other aspects, more holistic approach, so that we can make sure that there's a good return on investment. So I think last slides is that, okay, we have worked a lot on resource constrained devices for IoT. Yeah? We have worked a lot on low cost, low power hardware, software, and also the optimization. We look at the integrated platform approach. We look also quite a lot to wireless connectivity, networks, security. I think that is the topic for the next panel. Maybe in my next presentation, I will talk more about that. Yeah? We talk about the trust, security, yeah? And we also focus a lot on the data science. So I still have some introduction about the IMEC. So if you still allow me a few more seconds for those people who do not know IMEC, and I will skip this. So IMEC, we are research institute headquartered in Belgium, already for 35 years. We're actually a spin-off from the Catholic University of Louvain, which is the, I believe, the second oldest university in Europe. We have representation offices in several countries, including India, in Shanghai, Japan, even now we have in Brazil and Russia. But for R&D centers, actually Taiwan was the first R&D center of IMEC outside Europe. We started 10 years ago in the Hsinchu Science Park. Last year, December, we set up a new R&D center in Orlando, in Florida. And I think we try to copy the same model as we established successfully in Taiwan. We hope that we can copy also in Florida. So basically today, the main R&D centers is in Belgium, Holland, Taiwan, and just started in Florida. Total amount of the staff is 3,500 researchers. And I think in addition, we have about 10% more supporting staff in HR, finance, etc. I think very important is that we have 74 different nationalities working at IMEC. You know, Belgium is a very small country, even smaller than Taiwan. So statistically, we can only have one Nobel Prize winner every 50 years. So how can we have an outstanding academic performance if only we employ Belgian citizens? It's not possible statistically. So we are happy we invest a lot in the infrastructure, and we can attract the talents from worldwide, including also from Taiwan. This is a snapshot of some of the customers we work with. I think some major mobile phone company, actually when I look here on the table, I think everybody here is our client. But we also work a lot with the startup companies. So it's a very, very diverse customer network, upstream, downstream, supply chain. I think that's a very important asset. I mentioned during the coffee that what is for us very important is to be independent. We do not belong to government. We do not belong to any big company. We are an independent organization. So by working and talking with all these companies, we can form our own opinion and define our own roadmap. And we try to keep it at independence. Of course, we try to drive a semiconductor roadmap. That's the core of what we do. I think still today, 60% of our staff is working on how to reduce the transistors. And we also do some investment. But at the end, what we try to achieve is to make the devices smaller, more cost effective, and with low power. 谢谢大家。